It is important to have an understanding on the neural circuitry behavior such as sensory perception, memory, and learning, which in the future will help us provide an insight into how the human brain forms memories. The Drosophila melanogaster, the common fruit fly, is a perfect model organism to help us give a stronger understanding. Tyler A. Ofstad and his colleagues have been studying the Drosophila melanogaster and its ability to use spatial memory to navigate. In 2011, Tyler Ofstad published an article about the visual place learning in the Drosophila melanogaster, and this particular article is what I would like to discuss with you today. In a fly's brain, neurons in the ellipsoid body are necessary for the visual place learning, and when they are silenced, visual place learning will become dramatically impaired. It has been hypothesized that the fruit flies can remember spatial locations within any given environment. An array of 64-inch squared individual addressable thermoelectrical modules put together in an 8x8 grid was developed by Taylor A. Ofstad and his colleagues to control the heated environment. This array constructs the floor of the test arena and is covered in black tape to maintain the heat. It is important that the flies did not escape the arena, so to prevent this, a 3mm high and 203mm diameter heated aluminium ring covered with a glass disc and slippery surface was situated around the perimeter of the arena. Positioned around the outer perimeter of the arena were LED display providing visual cues. The experiment was conducted in 10 training trials which ran for 5 minutes each. After each training trial was complete, the cool tile and the corresponding visual panorama are rotated 90 degrees clockwise or 90 degrees anti-clockwise, shifting the location of the cool tile. An 11th trial was conducted where the visual cues were rotated the same way as the previous tiles, but the cool tile was eliminated. Doing this test gives a greater understanding of the fly's spatial memory. To verify the fly's ability to use spatial distinct features, a further test was conducted where the cool tiles were still randomly located, but the display remained stationary throughout. The visual panorama provided no consistent location cues, but the weaker spatial cues are still available for the fly to use. During the first trial, it can be seen that 94% of the flies eventually located the cool tile. Over the course of the 10 trials, it can be seen by the red line on this graph that the time it took for the flies to locate the cool tile improved dramatically as they took a shorter route. The flies that trained in the arena where the display remained stationary showed little improvement in the time taken to locate the cool tile. It can be seen on this graph that during the 11th trial, the flies had used the peripheral visual landmarks to indicate where the cool tile should be, as the flies searched in the quadrant where the tiles have been previously located. It can be proven from conducting the discussed methods that flies can learn spatial locations by using distal visual cues and the memory to guide navigation. The flies can obtain these memories for at least 2 hours, and this was confirmed by varying the times between the tests. In 2013, researchers in Vivek Jayaman's lab finding supports that the hypothesis of this report, as they gathered evidence that inside the fly's brains, in the ventral complex region, there are neurons responsible for behavior seeking out safe places in restricted environments.